So for number 1, the GCF is 1, so we're not going to factor anything out because it's just 1. So what you do is you multiply first and last, and that gives you 72 n squared, and you're looking for factors of 72 that add up to negative 17. And those factors are negative 9 and negative 8. Okay, so we did this earlier on. You bring down the first term and the last one, and then I usually put it in a 2 by 2 grid. So you put 3n squared minus 9n minus 8n, and then 24. The greatest common factor of these two terms right here is 3n. Then something times 3n is 3n squared equals 3n squared. That would be n. Then something times 3n has to equal negative 9n. That would be minus 3 or negative 3. Then something times n equals negative 8n. So that would be negative 8. So and then you always check, is negative 3 times negative 8 equal to that number? Yes, it is. So your answer is correct. So it would be n minus 3, 3n minus 8. So for 2, the GCF is, I look at the x's and the y's, they have an x, y in common. So 4x squared minus 49y squared is what I have as my other factor. And I recognize that this is the difference of two squares right here. Okay, and there's a special pattern for factoring the difference of two squares. So I'm going to bring down my xy and then set up my two parentheses. So the square root of 4x squared is 2x. So I write it here and here. And the square root of 49y squared is 7y. So I put it here and here, and then plus and minus in between. And you're done. For number 3, the greatest common factor is 5, so I'm going to take out a 5. Okay? And whenever I see that the leading coefficient is 1, because see, the 5 is out of the picture. This is no longer going to be used in factoring. We took it out. So whenever this is 1, I basically just look at this number back here and factor it to give me this number. It's just a little bit faster. So factors of negative 12 that add up to 4. So I have negative 1 times 12, negative 2 times 6, and negative 3 times 4. Of these three pairs, this is the one that gives me 4, right, when I combine it. So that just tells me that I'm going to have factor squared of x squared is x minus 2y. I have to include the y because there's a y squared over here. And then x plus 6y. Okay, and there's the answer. Number 4 does not, well, it has a GCF equal of 1. So there's really nothing we can factor out to make the numbers or the terms smaller. But notice I have 4 terms, right? So what I'm going to do is I'm going to factor by grouping. But the way I group them is in a 2 by 2 grid. So I just write them in order as I see them. So 3x cubed minus x squared y, 12x minus 4y. And then the GCF, or the greatest common factor in these two, is x squared. Then something times x squared is 3x cubed. That would be 3x. Then something times x squared is negative x squared y. That would be negative y. And then something times 3x has to equal 12x. So that would be 4. And then as your final step, you check, is negative y times 4 equal to this? And the answer again is yes. So your factors are 3x minus y times x squared plus 4. And because this is not a difference of squares, it does not factor any further. Okay, that's all for that one. So for number 5, we're back to a trinomial. And the GCF that I see here is x squared y. So I'm going to take out x squared y. So my remaining factor is 2x squared minus 3x minus 20. Okay, because the x squared y was factored out of each term. So now I multiply these two and I get negative 40x squared. And I check all the pairs of factors of negative 40. I want my difference to be negative 3. So negative 3. So I know that the bigger number has to be negative. So negative 40 times 1, negative 20 times 2, negative 10 times 4, negative 8 times 5, right? And that's it for the pairs, right? So of the 4 pairs, this one gives me negative 3. So I'm going to use that to break up negative 8x, 5x, and remember you bring down the 2x squared and the negative 20. I'll just work up here. I've got a little bit more room, so I'm going to put 2x squared minus 8x, 5x. So number 5, we have, let's see, I was setting up the 2 by 2. And so the greatest common factor up here is 2x. Then something times 2x has to give you 2x squared, so that would be x. Then something times 2x has to give you negative 8x, so that would be negative 4. And then something times x has to equal 5x, and that would be 5. And then you check, is 5 times negative 4 negative 20? The answer is yes. So then your factors are, don't forget to bring back the x squared y, so that's the first factor. And then 2x plus 5 times x minus 4. So number 6, the greatest common factor for this problem is 3xy, so I'm going to take out 3xy of each, factor out 3xy out of each term. So that gives you 3x squared plus 11xy plus 10y squared. So you multiply these two, and factors of 30 that add up to 11 are going to be 5 and 6. Okay, you bring down this term, bring down this term, and that's what you put in the box. So 3x squared, 5xy, 6xy, and 10y squared. So the greatest common factor up here is x. Then something times x is 3x squared, that would be 3x. Something times x is 5xy, that would be 5y. And then something times 3x is going to give me 6xy, that would be 2y. And then you check to see if this times this gives you this, and it does. So don't forget you took out a GCF of 3xy first, then x plus 2y, and then 3x plus 5y. And there's the answer. So the GCF in number 7, the greatest common factor is 8ab cubed. Okay, when you factor that out, you get 2a squared b, and then you get 5ab squared, and then you get 1. Okay? And number 7, this trinomial right here does not factor anymore because the b right here is not squared, so I can't break it up. Okay? And I have a b squared right here, so there's no way of factoring this one. So this is as far as we go. Number 8, notice how I've got a 4th power and I've got a squared right there. So I could treat this as a quadratic. So factors of 36 Okay, factors of 36 that add up to 37 are negative 1 and negative 36. Those add up to negative 37. So then when you factor, you have to take the square root of t to the fourth, it's t squared minus 1, and then t squared minus 36. Okay, now these two are each difference of squares, so you factor it further. So this is going to be, for t squared minus 1, it's going to be t plus 1, t minus 1. For t squared minus 36, it's going to be t plus 6 and t minus 6. So this is a completely factored form of number 8. So the greatest common factor of number 9 is 2ab. When you factor that out, you get a to the 6th b squared minus 144. Okay, so this is difference of squares. Okay, so I'm going to bring down the 2ab and then just set up my two sets of parentheses. The square root of a to the 6th b squared is a to the 3rd b. So I write it in both factors. And the square root of 144 is 12. And then plus, minus. And that's it. So number 10 is another 4-termed polynomial. So I'm going to just fill in the little box. 35a squared b, negative 5a, negative 7ab squared, and b. So the greatest common factor in the first row right here is 5a. Something times 5a has to give me 35a squared b, so that would be 7ab. Then something times 5a has to give me negative 5a, that would have to be negative 1. And then something times 7ab has to give me negative 7ab squared. So that would be negative b. Okay? And then you check, is negative 1 times negative b equal to b? The answer is yes, so there are your factors. 5a minus b and 7ab minus 1. So the greatest common factor of 11 is a squared b squared. So I'm going to take that out of each factor, factor it out. So I get 6a squared minus 11ab plus 4b squared. So I multiply these two and I get 24a squared b squared. Factors of 24 that give me negative 11 are negative 8ab and negative 3ab. Okay, so you don't have to bring down, you know how I always bring them down like that. You don't have to do that. You can go straight to the box and just make sure you put in the first term there. The two that I just, that I found factors for, so negative AB, negative 3b, AB. And then the last term right here in the last remaining box. So the greatest common factor here is 2a. Something times 2a gives me 6a squared, that would be 3a. Something, well, I could do this one first, doesn't matter. Something times 2a gives me negative 8ab, that would be negative 4b. And then something times 3a gives me negative 3ab, so that would be negative b. And then you verify, is negative 4b times negative b equal to 4b squared? The answer is yes. So your answers are, don't forget the factor, the GCF. So it's going to be, I'll put the answer right here, a squared b squared 2ab times quantity of 3a minus 4b. So on number 12, the greatest common factor is t plus 3. Notice how they all have that in common. So I'm going to factor that out. So then I have t squared plus 6t plus 9. So factors of 9 that add up to 6 are 3 and 3, right? So then this is t plus 3. And notice how it's the same number, so it's going to be t plus 3. I can write it twice or just put a square right there. Either one is fine.